Lesson 4.5, we're going to be writing functions today using function notation. Before we do that, let's do the individual warm-up where we factor each of the binomials. This is what we did yesterday. Let's start with number 1. We have 36x minus 15. So there's two terms. Let's write down the numbers for each of those terms. So 15 and 36. And then the factors. So the factors of 15, 1 times 15 and 3 times 5. For 36 we have a bunch. We have 1 times 36. We have 2 times 18. We have 3 times 12. 4 times 9. And 6 times 6. What's the greatest common one between those two? So this would be the second step of our four-step process that we learned yesterday. So the second step would be find the greatest common factor, which is 3. The third step says then, okay, take that number, put it outside the left end parenthesis. And then the fourth step says, ask yourself, 3 times what number, or 3 times what gives us 36x? Well, 3 times 12x gives us 36x. Now, 3 times what gives you negative 15? Well, 3 times negative 5 gives us negative 15. So there's your answer in factored form. For the next one, 8x squared minus 40x. Two terms again. Write down the two numbers, 8 and 40. We know that the factors of 8 are 1, 2, 4, and 8. We found this multiple times in last lesson. The factors of 40, so 1 times 40. 2 times 20, 4 times 10, 5 and 8. So that was that's to help us find the greatest common factor, which is going to be 8. So that was step 2. Step 3, write that outside of the left end parenthesis, and we're going to write it along with an x. Okay, so we see that this term has an x, this term has an x squared. You factor out the lowest number of x's, so you pull out an x. Now you ask yourself, 8x times what gives us 8x squared? Well, x. 8x times what gives you a negative 40x? Minus 5. And this is your factorization. Okay, function notation. This right here is read f of x. It is not read f times x. Okay, two different things. And this is used to show what value is being input into the function to get an output value. So you can think of, so if we have an equation y equals 2x plus 3, you guys have all seen that equation. Right? If we were to put this in the function notation, what we could say is f of x equals 2x plus 3. So these are the same thing, just two different ways to write it. So just think of f of x as, your y. Now in the following examples, we're going to do all of the evens, and it's up to you to do all of the odds. And we're going to write a function rule that represents each situation. Be sure to find the variable used, and we're just going to focus primarily on that. Alright, so the second example problem here, it says a babysitter's earnings E are a function of the number of hours n worked at a rate of $7.25 per hour. So we have two variables. We have E, which is total earnings, and we have N, which is equal to number of hours. Alright, so we got to write a function rule. So here's what you're going to ask yourself. What depends on what? So does the number of hours that you work depend on your total earnings? Does that make sense? Or does it make more sense to say that your total earnings depend on the number of hours? If you say the second statement makes more sense, you're correct. Total earnings depends on the number of hours you worked. So I wrote down, so because of that, E is your dependent variable and N is your independent variable. And all you need to really understand from this is that the dependent variable is what gets capitalized. So if we come back to the problem, alright, and actually we're doing the second one and I wrote all over that, so I'm going to have to erase, unfortunately. I apologize. You can always kind of go back. Alright, so our E is what gets capitalized, our dependent variable, and our independent variable N is what's in parentheses and is lowercase. Right, and then go ahead and write the rule like a normal expression that we've done in previous sections. So E of N is going to equal 7.25. The per would mean multiplication, and we're going to multiply by the number of hours, H, which is represent with an H. So there's your function rule. Alright, let's continue to do more problems so you start to get the hang of this. Alright, we're going to look at number 4. A plumber's fees F are $75 for a house call and $60 per hour H for each hour worked. Alright, variables. F equals total fees. H is the number of hours worked. Okay, ask yourself, what depends on what? Well, the total fee that you owe depends on the number of hours the plumber is there. So this is your dependent variable, and this is your independent variable. Which one gets capitalized? Your dependent. So we're going to capitalize the F. In parentheses, we're going to put the lowercase h. So this is in function notation. Write the expression just like previous sections. So $75 is what the plumber charges for a house call. That's what he charges you just to come to the house. That's the flat fee. So 75 plus, and then he charges $60 per, means multiply, hour H. So this is the rule. Okay, number 6. Again, we're doing the evens. Jacqueline's earnings M are a function of the number of lawns N she mows at a rate of $12 per lawn. Alright, your two variables. M. Total earnings. N. Let's write that. Let's write N down here. Number of hours. I'm sorry. N is the number of lawns. Okay. So what depends on what? That's what you want to ask yourself. Does the number of lawns depend on her total earnings, or does Jacqueline's total earnings depend on the number of lawns she cut? Well, Jacqueline's total earnings depend on the number of lawns she cuts. So total earnings is your dependent variable, number of lawns is your independent variable. All you need to know from this is you capitalize your dependent variable. So you capitalize the M. You put the N inside of the parenthesis, and that's lowercase. And then go ahead and complete the rest of the expression, or write your expression. So she mows at a rate of $12 per lawn. So, all right, number 8. Mr. Infalvi's age X is 5 months younger than Mr. Leskowitz's age Y. Alright, so X equals Mr. Infalvi's age, Y equals Mr. Leskowitz's age. Okay, what depends on what? Mr. Infalvi's age depends on what Mr. Leskowitz's age is. So Mr. Infalvi's age is going to be the dependent variable, X, and Mr. Y is going to be Mr. Leskowitz's age. That's going to be the independent variable. And so we want to make sure we capitalize the X. So we go at capital X, and then in parentheses we have our lowercase y. Alright, and then we have this here. So Mr. Infalvi's age X is 5 months younger than Mr. Leskowitz's age Y. So what is going to give us Mr. Infalvi's age? Taking Mr. Leskowitz's age, which is Y, and then subtracting 5 from it. Right, and then finally, the second one here, on the second page, the number of pages remaining P in your science pack are a function of the number of nights N that you worked on the packet. The packet was 12 pages long and you completed 13 pages each night. So your variables, P equals pages remaining. And N is the number of nights you worked on the pack. Alright, so what depends on what? So the pages that you have remaining depend on the number of nights that you worked on it. So that's your independent variable. Now all you need to remember from this is just you capitalize your dependent variable. So you capitalize the P. In parentheses, you write the lowercase n. Alright, so it says that the packet was 12 pages long, and you completed 3 pages each night. So you start with your 12 pages, and then you're subtracting, so the completed would mean, you subtract from that 3 pages per night. So minus 3n. And that becomes your function rule. And that's the end of 4.5 day 1 lesson.